Hello and welcome to another edition of the Future World Alliance Speaker Series. We're very excited to bring you today's talk. The Future World Alliance works to empower people to drive economic and social transformation. We believe that through collaboration and collective action, we can create a world where the abundance of human ingenuity and creativity is not constrained by the limits of human nature. Our focus is on responsible AI education, particularly K through 12, internationally. Thank you, and we hope you enjoyed today's speaker session.
Welcome everyone. So today we have Dr. Sherri. So let's pass on the stage to her. Thank you so much.
All right, thank you. Sherri Feinzig. I am an industrial organizational psychologist, which I know is a mouthful, but that background is relevant to the talk today. So essentially what an IO psychologist, IO for short, IO psychology refers to the study of human behavior in the workplace. So really understanding things like employee attitudes, motivation, how to select the best people for jobs, really runs the gamut around those types of areas. I also have gotten involved quite a bit in my previous role, which I'll talk about in a minute as well, in the areas of artificial intelligence and machine learning. Had the opportunity to work with Phaedra Buonadiris, which was my connection to being with you here today. So that was when I was at IBM. I spent most of my career at IBM in a number of different roles. I actually left the company about 5.5 months ago and took a new role at Marsh McLennan. And that's where I am today as the Global Head of Workforce Planning and Analytics at Marsh McLennan. I also have a side gig that I'm taking a bit of a breather from, but adjunct professor at New York University, where I teach in their Human Capital Analytics and Technology program, master's program, and co-author of the book, The Power of People. So that is me. And what I'd like to do for this conversation is really kind of start out with a question. And the question is, and we're a small group here today, so feel free to be interactive during this conversation. But the question is, what happens when AI, machine learning technologies, algorithmic technologies are built and deployed without the benefit of having domain expertise as part of the process? And I'll ask that question in the context of two different domains or areas where algorithms are used. One is in the context of social media, and the other in the context of recruiting. So that's my world, HR, talent, hiring people for jobs. So does anyone want to just throw some ideas out there to answer this question? What happens when a bunch of data scientists and analysts are in a room working with data sets, building algorithms without having domain experts to work with to really understand the context in which their algorithms are going to be deployed in the real world? Any thoughts?
Sort of a formal name would be bias.
Yes, indeed. All right, let me ask a little bit even more specifically for each of those. So in the social media realm, what happens when algorithms are built, deployed, optimized without people who have expertise in, let's say, the area of cult indoctrination? And on the recruiting side, similarly, what happens when you're building and deploying algorithms without getting input and guidance from people who have training like I do, which is expertise in testing, in job selection, and disparate impact, which brings, kind of touches on that point around bias, meaning without understanding that sometimes algorithms, if they're making predictions, as you would in the recruiting side, sometimes maybe they work better for other people than for some groups than for others, and that would be an example of disparate impact or bias. So I think we've all seen the results of what happens in the social media world with algorithms that are really not focused on where things could go wrong, just focused on the objectives of the people who built and deployed those algorithms, which is, maximizing user engagement and so forth. And we've seen the results of the proliferation of bad information that impacts society in very unfortunate ways. And on the recruiting side, many people by now are familiar with the Amazon example, but if you're not, the short story there, Amazon built an algorithm with their internal data science team to try to predict who can be successful hires in the future. They built that algorithm based on their existing data of people who were already employed by Amazon who were deemed to be successful. The population of people that were historically employed by Amazon at the time, predominantly male, lo and behold, the algorithm did a remarkable job of predicting that the company should continue to hire predominantly male, and really an artifact based on the limited data set on which the models were trained. So kind of the larger question here for me that I think is worth asking is what happens when these types of technologies are built and deployed with a goal in mind, where the people building and deploying them are kind of maniacally focused on that goal they're trying to achieve without thinking enough about what could go wrong. And what I'm hoping to convey during the course of the conversation today is that we really need to spend at least as much time thinking about what could possibly go wrong and mitigating for it as we spend on what are we trying to achieve when we build an algorithm, so that we can in fact achieve those objectives, but without the collateral damage that can happen when you don't think about the other side. So just to kind of bring the point home, I think when social media algorithms were built originally, there certainly were high aspirations of what could be achieved with these technologies, things like bringing together communities who need to support each other, people who are going through something, bereavement groups or what have you, struggling with a rare disease, and being able to connect people and form those support communities. The Arab Spring, I'm sure everyone can recall, and all these great things that can happen by bringing the world together through these technologies. But then we also saw, some of the ugly reality that resulted when these technologies were in fact built to maximize user engagement and human behavior being what it is. And as an IO psychologist, I appreciate human behavior being what it is. It ended up with quite a bit of negativity as well. There are great aspirations, so much potential with technologies, but there's still a lot of hype as well, and we see what happens when these algorithms interact with the messiness of reality. So being in the HR world, I still, the hype is still there as well as the hope and the aspirations, and there continues to be a push to bring these technologies into the HR and talent management world as well. And over the years, I've tended to hear three main arguments for doing so. One is that humans are biased. So what if we can get rid of that bias by being purely objective and use algorithms to make decisions instead? Another is around efficiencies. If we think about back to the recruiting world, sometimes companies will post an opening for a position and you can get hundreds, literally thousands of people applying for the job. How is a recruiter supposed to sort through all those resumes and applications? Oh, let's apply some technologies to it and really drive those efficiencies. And the third is that algorithms are highly predictive. So let's take advantage of that capability as well. So there is an element of truth to all of these, but it's not the full story. So yes, humans are biased, and we are biased in our decision making, and it is humans who are building algorithms and choosing what data sets to include in those algorithms, like the Amazon team did. And so all of those biases that we bring in our decision making are brought to bear when we build algorithms as well. So really important to recognize that, and for those of us who do recognize it, to convey that when we're out working with people who are going to be, either thinking about purchasing, using these applications, or actually being subject to them. In terms of the efficiencies, yes, these technologies, automation, incredibly efficient, but also important to recognize that it takes a lot of work to get them right in order to get to that efficiency level without having the collateral damage along with it. So all of the work involved in building, deploying, selecting the right data sets, tuning those models once you put them out in the wild and they start ingesting more data, the debiasing, that's important and necessary. And I'll share an example, an actual real world example towards the end of the talk around that. And then the ongoing monitoring as these technologies, these algorithms ingest more information, they continue to change. And all of that is hard work. And I think that a lot of people, particularly purchasers of these technologies, are enamored with the promise of the efficiency without realizing all of that hard work that has to go into it. And then on the predictive, yes, these algorithms can be highly predictive. We often see, so-called accuracy statistics of 95%. But we really need to think about what is it that they are predicting. And of course, these algorithms are built on historical data sets, so they are recreating the past, again, as we saw in the Amazon example. If we're looking to not just replicate the past, but actually create a different and hopefully better future, then algorithms are on their own, not the way to go. So I'm just going to walk through a scenario quickly to start to show, and I'm going to touch on a couple of use cases of, again, the implications of what happens when we don't have that domain expertise and the right thinking about what could go wrong when we actually deploy the algorithms. So this is a hypothetical made-up example, but just imagine you're back in your college days and you want to go to grad school. And so in order to apply to the graduate school programs that you're interested in, you have to take an entrance exam. Okay, this exam is associated with success in the program, so it makes sense that you would take that. You're fully qualified for the program, you're prepared for your exam. But imagine, again, this was 2 years ago, and it's during the pandemic. And if you, I'm sure, can recall, people were not being physically seated in testing centers to take exams, and the only option is to do it online. But unfortunately, you're about to sit down to take your test, and a nor'easter blows through, or some sort of storm blows through, and the power in your immediate vicinity goes out, and you can't take the exam. You can't get online. You try to find another place to take the exam, but you can't. It's a pandemic. Nothing's open and available to you, and now you can't apply to grad school. So is this fair? Thoughts, reactions? Does this seem like a fair situation? Do I still have my audience out there?
I'll jump in and say no. Seems obvious.
Yep. Okay. Thank you. I can't. The only thing that I can see is my screen. Usually, when I'm in web meetings, I can see participants. So I apologize, but
No, sorry.
So thank you for that. I know you're still there. Okay, so I'm going to run through another scenario quickly and agree with you that that wasn't a fair situation. So now imagine a job application as opposed to a grad school application scenario. Someone named Catherine Jones, she's applying for a job at a call center, really needs a job. She's fully qualified. She submits her application through the online applicant tracking system, which is a very typical way to apply for jobs. And then behind the scenes, unbeknownst to Catherine, an algorithm determines that she's unqualified because she's been assigned a low credit score. The employer purchases these credit scores from a supplier. There are 3 major suppliers of credit scores in the U.S., and the credit score associated with Catherine says that she has bad credit. And so, but really the situation, again, unbeknownst to Catherine, is that it's not even her score that's associated with her, but it's preventing her from getting the job. Not only that, she never hears back. She applies to several other jobs at other companies, but they're all using the same credit scored supplier, so she never hears from any of them. Is this fair?
No.
No, thank you.
Yeah.
I would agree. But I don't want to stop there. I want to now look at these comparisons, these scenarios side by side. So in scenario one, applying to grad school, you followed all the procedures required to apply. You were prepared. The exam's relevant to what you're trying to do, but your plans were thwarted through no fault of your own. In this scenario, you know precisely what sabotaged your application process and why. You sat down to take the exam, no power. You know what got in your way, and you could potentially appeal because the school, you can, contact the schools you're applying to. You probably could actually reach a human being, and chances are you could probably find a way to complete the application process because people would be pretty understanding in that scenario. On the Catherine side, she also followed all the procedures, and also her plans were thwarted through no fault of her own. But the difference is she had no idea why, and she has no one to contact. So she will never even know that someone else's poor credit score is preventing her from getting the job. And furthermore, what's the relevance of a credit score to job performance anyway? Many companies use credit scores to screen people out from those hundreds and thousands of applications that are coming in. But it's really not the best way to decide whether someone's a good fit for a job or has the skills, capabilities, requirements for the job, because it is not job relevant. So a lot going on in that scenario. And while they are somewhat hypothetical, scenario two is actually built based on a real life situation. So these things actually happen. And it's very unfortunate because people don't even have any recourse to, first of all, understand why their resume went into a black hole and they never heard again. And even if they did, how to actually address it. So really important to understand also, going back to how algorithms work. Again, they're based on projecting the past onto the future. And so this can end up perpetuating historical inequities that are systemic to the past. So meaning the poor are, in the world of algorithms built this way, expected to remain poor forever. Students from failing schools will fail. People lacking job experience will never get hired because they're never going to have the job experience to get them hired. So those are the types of things to be aware of. And I'm probably preaching to the choir. So I will move on to another example that I think is also pretty telling. So again, thinking through not just what are you trying to achieve with your algorithms, but what are the maybe unintended consequences as well. So this example is going to focus around software that's very commonly used for scheduling shift work. So retail workers, people in the hospitality industry, where the organization is trying to optimize having the right number of people on a given shift at a given time. So you don't want to overstaff when times are slow. You don't want lines out the door when times are busy. So there are these great software applications out there that are, based on logistical algorithms to try to figure out what's the best way to do that. And they work remarkably well. And so the outcome for the retailers, the people buying the software, are things like greater efficiency, lower costs, increasing their margins. And of course, these are key metrics for leaders of these organizations. So they get rewarded for hitting those metrics. And boom, optimized workforce isn't that great. But we need to think about the impact on the actual workers who are subject to these algorithms as well. And what the research shows, quite extensive research, is that the outcomes are quite bad for people who are the workers in these situations. So oftentimes their hours are changing their schedules are changing weekly. So they have very unpredictable hours. They may get called saying you had a shift scheduled, but don't come in, we don't need you, or being called in to work shifts that weren't planned. And so it makes it very hard to live your life and plan the rest of your life around it, especially these are typically low paid jobs. So people often need a second job to pay the bills, or they're trying to work their way through school. Very hard to do that and schedule other things when your job schedule keeps changing. Even worse for people who have to arrange childcare. And the result is a lot of stress and anxiety, sleep deprivation. People are sometimes, called in to close a shift at 11 p.m. and then they're called back to open the store at 5 a.m. It's a really tough way to work. And so while it looks like the organization is getting great outcomes, their workforce isn't, and it has implications on society at large. So another example of thinking holistically around the impacts of technologies. And then one more that I've been focused on recently, which is monitoring technology at work. We are all monitored quite a bit. And there are more and more of these technologies that are being, built and promoted to create really efficient, productive workplaces. And especially as so many companies have moved to a remote world, helping managers to understand whether their workers are working or not when they're working remotely. And so the New York Times did a really good piece on this relatively recently, a couple of months back. And within the article, they quote someone who is a co-creator of one of these technologies called WorkSmart, a gentleman named Federico Mazzoli, and specifically, they quoted him twice. So it was kind of a before and after. So this, I think, is a really good example of distinguishing the intent from the outcome. So in this case, this software was designed to be like the Fitbit of productivity. So really driving motivation, driving worker accountability so that we can keep track of how people are spending their time. So this is software that does things like track every click on the computer, track what websites people are visiting, even taking screenshots periodically of people's screens to see what they're working on. So constantly surveilling people's activity while they're on the clock, so to speak. And a quote from Mr. Mazzoli when he was building this technology: once you see those metrics, those insights, something changes, you realize how much you waste doing nothing or just multitasking and not accomplishing stuff. So he was viewing this as not only beneficial to the employers, but to the workers themselves, to realize, oh, look at this, I've been wasting a lot of time, but now that I see these metrics and this information, I can be much more effective. Isn't that a great thing? He started using his own technology a couple of years later, and his perspective changed once he was actually subject to using his own creation. And in fact, what he found was the constant monitoring actually created a lot of anxiety for him. And he also started to lose confidence in the accuracy of the tool's metrics. So if you think about it, and just to give you an example, preparing for this talk, yes, I spent a lot of time on the computer putting my slides together, but I also spend time physically reading things like the New York Times and other sources, a physical hard copy of the paper. So that would have been recorded as unproductive time by the software, even though it was quite productive. And that's just one minor example. Maybe I would have printed out my content and then edited it off to the side. That would show up as unproductive time. And the inventor, one of the co-creators of the technology, experienced that himself. So his quote after using it is, "Some days you're just moving the cursor around just for the sake of it." And of course, now there's technology on the market that does just that for the worker, moves the cursor around just to show that you're being quote unquote productive. So this is kind of a lose-lose situation. The employer thinks that they're tracking people's productivity, but they're really not measuring the right thing. It's driving behavior to serve the algorithm as opposed to driving behavior to serve the organization. And he ended up leaving his own organization after experiencing it. So let me pause there. Are there any questions or comments before I continue?
I have one. This is Ross. Just an observation back to your. I think there's probably some. I don't know what you'd say. Maybe I want to say convoluted, but maybe that's not it. But the relationship to credit score to hiring, for example, some could make a case that the behaviors that lead to a low credit score would lead to low job performance. I'm not agreeing one way or the other, but some would make that argument. And so there's in some of these examples, there is an alternative side to consider. And I think you make a great point of you need to really look at both. Like a lot of times, without whether it's domain expertise or whatever you say. So I just was thinking that as you were talking, like, okay, I could see where people would make some of these cases, but I think you're right. And I think, overall sort of one sort of observation or takeaway is transparency in these systems is a lot of what's missing.
Yes, great points, both points. Thank you. Absolutely, the transparency piece. And by not, I'll frame it in the positive, by opening up your ideas and your approaches to diverse audiences who could input to your way of thinking and challenging it is the way that these types of things that you otherwise would have overlooked can come to light and be addressed before you put your algorithm out there and then the problems get discovered. So that transparency piece is super important. I agree. And I really like your question or your point around, well, maybe the credit scores are job relevant. In some jobs, they might be, because people actually have to be certified if they're financial advisors, for example. However, the way to approach it is not just to say, it seems logical that a credit score would be correlated with the same behavior as integrity on the job, and therefore that makes sense to use. You need to test that out and do really ideally an experiment and let the data bear out whether that assumption is true or not. If you can demonstrate that something like a credit score is predictive of whether someone's going to be successful on the job, okay, then it's valid and it's okay to use that as long as we make sure that it doesn't discriminate by different demographic groups, et cetera. So that's a whole piece of work that needs to be done. And this is the job of the IO psychologist, is to bring that expertise into these conversations. And similarly, in any other domain, to bring the right expertise in to make sure that you're thinking through whether what you're doing makes sense or not, whether it's legal or not, whether it's actually achieving what you think it is or not. So it's a great point. And the action is to test out those assumptions rather than just take them at face value, because it could very well be the case, and it is in the case of credit scores, that they are not predictive of job performance, generally speaking. And so you end up screening out great candidates and probably candidates of lower socioeconomic status and so forth, and therefore you're discriminating. So I hope that provides more context.
Yeah, no, agreed. And you'd really want to get credit scores of your existing employees, which I don't think I'm not sure that's even legal.
Right. So it's complicated, but point well taken. And again, my guidance is work with the right domain experts to know what makes sense, and to test out the assumptions rather than just taking them at face value. Thank you for that. So I don't want to be.
I'm sorry.
Yep.
I've got a question out of curiosity. Right? Okay. I'm just wondering, does getting hired because a recruitment firm, got you the job, equal being successful on the job?
I'm sorry, I'm not sure I understand the question.
So there are recruitment companies out there. They help with, getting they help with submitting applications, recommendations, and all of that. I'm asking, does getting hired because recruitment firm help with application? Does that equal being successful on the job? Eventually.
So whatever mechanisms the recruitment firm is using to make a decision about whether someone should be recommended for a job or not has to follow the same approaches legally and logically as an employer directly hiring an employee. And if I'm trying to really understand the nuance behind your question, I wouldn't assume that because a recruitment firm puts someone forward that they're necessarily going to be the right person, but that is what they're paid to do, is to select the right people. Did that address the question, or am I off target?
Oh, yes, thank you.
Okay, all right, thank you for that. Okay, so not all doom and gloom. I want to talk about what we can do to make sure that that we're getting things right with our algorithms. So, after we've built and deployed them, and they're out there in the wild doing their thing, just questions that routinely we should be asking ourselves are we checking for model drift? Because as I mentioned, as these models take in more information, they learn and they will change their behavior. And it could be that bias ends up creeping in, even if you did all the good work up front to make sure it's not there. Checking for false positives and false negatives. Really important to recognize that models get things wrong. By definition, they will get a lot of things wrong. Hopefully they will be directionally correct, but when we come down to individuals, there will be instances for sure where the predictions are wrong, and there are implications for both false positives and false negatives. So, for example, back to the hiring context, what are the implications of predicting that someone's going to be successful, but then they're not? There's certainly big cost on the organization side for a bad hire. On the flip, what are the implications of predicting that someone would not have been successful when in fact they would have been? And that's where you get into the issue of screening out really good potential candidates that are just never going to make their way into the organization. And it's just a loss all around, and potential bias there as well. And then this is a piece that I'm going to give an example on, of just really looking at how is the algorithm working for different groups of people? Is it working similarly for everybody, or is it working better for some groups than others? And that's a really important nuance that, in order to answer that question, you really need to understand the data and look at the algorithmic outputs in different ways of cutting the data so that you could get to those insights. And of course, going back to the conversation around, well, a credit score might be a good indicator of job success. Let's do the experiment to find out, because that's the only way that we're really going to know cause and effect. And so just, some more good practices. We talked about transparency. Thank you for bringing that one up. Really, really important to be very clear and upfront and out there around what are your objectives for this algorithm? What assumptions did you make going into it? What data did you use to build it? What conclusions are you drawing, et cetera? Making sure that you've got explicit guardrails around how to use and not use the data. So, for example, if your model is directionally correct and at the aggregate level is providing useful information, it might be the case that that's fine. But if you start to use it to predict what any individual is going to do, that's where you're going to get into trouble, and you want to put those guardrails around not making individual decisions, but making aggregate level decisions, as just another example. Making sure that you're choosing the most relevant and high quality data to build your models versus what's most convenient, what do you happen to have on hand, and not pulling in superfluous, irrelevant data. So, for example, in the Amazon example, it may have been the case that people who had on their resume that they were on their rowing team in college it is a good predictor of job success, because maybe that's predominantly what they had on their staff in the resumes in the database that they analyzed, but actually it has absolutely nothing to do with job performance. So making sure that you're not bringing the irrelevant into your predictions as well. So just some ideas there. And then really want to emphasize that just because we can analyze a set of data and create an algorithm doesn't necessarily mean we should. In some cases, turns out probably wasn't a good idea. So need to keep that in mind as well. So then again, if you do observe that the model, you're doing those subgroup differences and it's not working as well for some as others, maybe it's predicting better for men versus women, or for older workers versus new hires, or whatever the subgroups are, really digging in to understand why is that the case? Why is it working differently for different groups of people? And trying to get at the root cause of that. And so this is a lot. You know, it's a lot for those of us who build algorithms to be worried about and thinking about and responsible for. And those of us building them absolutely have that responsibility, but you're not alone. So there are entities across the government world, the academic institutions, that have a role to play in setting policy, in conducting the right research, and putting the results out there. Consultants can play a role as a third party to come in and assess models for bias. And in fact, in New York City, that became a requirement for companies that are using algorithms to automate job hiring decisions and promotion decisions for citizens of New York City, starting in next year, actually, in January. So definitely a role for third parties to come in with an objective look. And then all of us as citizens, as people who are impacted by algorithms, who are users, consumers of them, to really understand how algorithms work, to demand transparency from our governments and so forth. So a role for many to play. So to kind of bring things home, I'd like to kind of close out with a real world example where we did really get into the details of how an algorithm was working at a client that had procured an AI model to do some human resources related work. So this is a piece of work that Phaedra and I actually did when I was back at IBM, and we had the opportunity to partner together. So a little bit of background here. The scenario is that this client had purchased an AI model that was designed to infer skills of their workforce. And this was for one of their units. It was for their technology organization. And so what that means is the algorithm would scrape information from, I think it was 5 different internal sources of data. So people's resumes, code they were writing, their performance appraisals, et cetera. So everything that was contained within the organization's firewall to try to ascertain or infer what their skills were. They started with technical skills, so things like data science, full stack developer, those sorts of things. And then they had an idea that, wow, wouldn't this be great if we expanded this approach to infer people's so-called soft skills as well, things like customer focus and drive and communication skills. And so they ended up using this model to infer 80 different skills, about half tech skills, about half the so-called soft skills of their organization of several thousand people. And through some work that we had done and conversations we had, we agreed with the client that it would be a good idea to test out how those models are working, and specifically if they're working equally well for different groups of employees within the function where the model was deployed. So, for example, as an IO psychologist, I had a hypothesis that maybe some groups of employees have more robust digital footprints than others. Maybe some people are more prolific around putting their great work out there than others are. So for example, maybe women are less likely to post information about what they're working on, or, have as much of a digital footprint as men, just as an example hypothesis, and it could be the case for different groups. So the client agreed it would be a good idea to kind of dig in and make sure that the model's working equally well for everyone. So that's how we set out to do this. We positioned it originally as a bias analysis, so we want to make sure that there's no bias in the model and the way it's working. When the client talked to their legal team, legal got a little concerned and didn't want to be working with an outside consultant, which was us, talking about things like bias and adverse impact and so forth. So we ended up repositioning the work, but I'm glad we did, to not just look for instances of bias, but to look for any instances where the patterns of the model output were not what we would have expected. So anywhere where the model doesn't seem to be working quite right, so that we can understand what's going on and fixing it. So that's the background. So what we did was, this was a train the trainer situation where we taught the client how to do this work. We wrote some code for them, handed off the code, they ran the analysis, gave us the output, and then we interpreted it and worked with them to understand the interpretation and what actions they can take. If we did find anything that didn't look quite right, how can we mitigate it? And so we had a 4-step process. The first step is preparing the data. So we had a data set of the algorithmic output, which are the scores from these models. So we just looked at a sample of 10. We did 5 technical skills and 5 soft skills. So what we did is we had the scores that were output by the model for every employee in the organization's business unit. And then we agreed on what our grouping variables would be. So originally we were thinking things like gender and race and age, which are the typical things you would do to check for bias. But as I said, we kind of repositioned it, and what the organization was comfortable sharing with us were 3 grouping variables. One was tenure, so how long has the person been working for that organization, which is not the same as age, because obviously we can hire experienced hires who will have a low tenure, for example. So one was tenure. The other that we ended up using was pay grade, which essentially was the same as job level. So professional, manager, director, VP and above. And then the third one, which actually made me chuckle, was a random binary variable. So there's no risk there. It's randomly generated, but it ended up being useful, which I'll explain in a moment why. So step 1 to prepare the data, once you agree on what your grouping variables are, to combine those grouping variables with the algorithmic output. Smash those together so that you can then do the analysis. And that's step 2. So what we did for the analysis is we wanted to focus on 2 things. We were looking for differences across groups. And so sometimes we observe a difference, but it turns out that it's just random noise. So there's no real difference there, because say you're looking at men versus women, maybe the means are slightly different, but the distributions overlap so much that it's really not meaningful. So to tease that apart, we do a statistical significance test. So that's step 1, and that helps us really tease out, is this a real difference or is it just random fluctuations? If it is in fact a real statistically significant difference, so probability tells us that there's probably a difference there, then we want to know, is it a practical difference? Is it big enough for us to care about? So that's another statistical test called effect size tests that we ran as well. So again, we taught the client how to do that. They gave us the data back, and then that's where the fun part happens. That's when you actually start looking at the output. So we used those 2 statistical tests to zero in where to look. So we only focused on where there was a statistically significant difference and the effect size was large enough that it was meaningful, we should care about it. And then this is very low, low sophistication, basic stuff, but we just looked at the data. We plotted it out in bar charts to look at the patterns to see what was going on. Is there anything that is unexpected? Or when we look at the patterns, does it make perfect sense? I mean, it may be the case, for example, that your low tenured people would score higher than your higher, or would score lower than your higher tenured people. So people have been in the organization a long time. You know, I'm going to make this up because this wasn't one of their real skills, but suppose the skill was political astuteness. Well, you'd expect people who have been in the organization around a longer time to score higher on political astuteness than people who you just brought into the organization. So that would be a pattern that makes sense. So we're not looking for, you know, every score to be identical across. That would be useless. But we're looking for that discrimination or differentiation to see if it's making sense versus where it's not making sense. And I'll show you some actual results to explain what I mean by that. I want to come back to that random variable. It was useful because we actually found that there were no significant differences in the two randomly generated groups. So that gave us confidence that our analysis was working as it was supposed to be. So something that actually made me laugh out loud initially turned out to be kind of a useful thing. So anyway, again, you're just exploring the data to look at, is there anything that looks unusual that I wouldn't expect to happen? And if yes, well, let's do two things. Number one, let's understand why, what's going on. And that will often mean going back to your source data. So there are 5 data sources. Is there one data source that in particular, for example, that's really driving that problematic pattern? So trying to get it at root cause, and that's where you're going to want to talk to your subject matter experts who really understand the data and that particular domain. And then if you do, you know, find that there are some issues still, taking mitigating actions to address it so that you can still get the great benefits of this algorithm going forward, but without the collateral damage that you wouldn't have even known was going on if you hadn't explored your data at this level. So we group those into 3 categories: data actions, people actions, and process actions. And in the interest of time, because we probably only have a few minutes left, let me show you some results. So again, this is just simple plotting the data. So these skill scores were based on a scale of 1 to 5, where 1 is, you know, virtually no level of the skill, 5 is you're an expert, you're a master at this, and then everything in between. So this particular chart is showing the average on that 1 to 5 scale. And, you know, suppose that this was tenure. So group A are your lowest tenured people. You just hired them in the last 6 months. Group F is your highest tenure. They've been with you 30 plus years, and then everything in between. And so what we see when we look at this pattern, and suppose this is communication skills. So we see that the lowest scoring groups are your lowest tenure and your highest tenure. So then we'd ask ourselves, well, does that make sense? As I was saying in the political astuteness example, it might make sense that your new hires are scoring lower, but would you expect that of your more senior people? Probably not. And so then you just start to, you know, work with the client or the domain experts to understand, does this pattern make sense? Or do we think that something is going on here, whereas rather than reflecting people's underlying skills, all we're doing is reflecting an artifact of the data. So when we dug into this, we realized, and this is so logical after you see the data and you see the results, if you've got a new hire and your model is dependent on people's internal digital footprints, your new hires haven't been there long enough to build out a robust digital footprint. So of course they're not going to be scored as high as people who have a more robust footprint. So right there, it's, oh, wait a minute, maybe this isn't the best approach for people who we're just bringing into the organization. Maybe we need an alternate way of estimating those people's skills. And if you think about it further, they should have skills because you just hired them, you're paying market rate for their skills. And if your internal skill assessment system is telling you that they don't have skills, that's problematic. And again, an artifact of your algorithm and the data it's relying on, as opposed to whether or not those people actually have skills or not. And then on the other end of the spectrum, maybe your veterans just don't bother keeping their digital footprints up to date because why should they? They've been there a long time, they're successful, maybe they don't even know that their data are being used in that way. So that would lead to some of the actions. So making sure that people know that you're using this information, putting the right guardrails in place to make sure that the scores are being used appropriately. Educate your more senior people if they don't know to keep their digital footprints up to date because it's feeding models. And for new people coming in, come up with an alternative way of assessing their skills because they don't have the rich data set needed yet in order to do so. And then another example on the bottom, where in this case, rather than looking at the averages, we're actually looking at what percentage of people scored a 1, scored a 2, scored a 3, a 4, or a 5 for a given skill. In addition, sometimes the system couldn't return a score at all, and so people would get a 0. So what does that mean? And are we seeing differences in those skills than we are in the other groups? So just to run through this really quickly, group J, why is it that they have the highest percent, 8% of zeros? And why do they have so many 1s in that group? Is that expected or is that not expected? Suppose that this was inferring sales skills. What if group J were your sellers? That would be concerning, but maybe it's because your sellers aren't doing things that create internal digital footprints. They're out talking to customers. And so again, artifact of the data that leads to poor results, poor outcomes. Also stood out to us. So this is real data, real output, but obviously I masked, the demographic groups and so forth. But we saw in this particular skill, nobody got a 5. No one scored the highest on the scale at all. And very few people got a 4. So that, raises the question of, do you expect that? Do you expect that you have no experts on that particular skill? Probably not. And then you start thinking through again, are there issues with the data? And so forth. So just to close out again, the people actions are things like communicating to people to let them know that their data are being analyzed, encouraging them to keep the source data up to date, empowering people to be able to raise issues, like going back to the Catherine Jones. She had no idea why she's not getting called back from the jobs. If she had that transparency to know that it's because credit scores are used, and if she had a way to check what her credit score was, or just as an example, being able to build into the interfaces where these algorithms are going to be deployed, these types of safeguards and usability aspects so that people can correct actions when needed. Those are some things to think about on the people side. On the data side, making sure that you're using only relevant data for the thing you're trying to predict, making sure that it's accurate and up to date and so forth. And the process, we talked about this quite a bit as well, building in an alternate path, building in guardrails, do's and don'ts of how to use and not use the data, etc. So I think we are up on time. So with that, I'm going to pause or close and see if there are any questions that I can answer.